Welcome back. In this module, we're going to talk about load balancing. In particular, we're going to talk about some load balancing concepts and then also take a look at some of the different load balancing topologies that you can deploy in your environment. I'm going to talk about the difference between layer 4 and layer 7 load balancing and why that's important to understand for Exchange 2016. And then finally, we'll look at DNS round robin. As we go through this module, and whenever you're thinking about load balancing or where you're directing your client access traffic for Exchange 2016, just remember that the client access services, which are also known as the front-end services, only authenticate and proxy connections to the back-end services. And what that means is no matter which front-end service a client connects to, they'll always be proxied to the mailbox server that is currently hosting the active database copy that hosts their mailbox. And the reason I point this out is because sometimes people put a lot of thought and effort into controlling exactly which Exchange server the client connects to, and don't really think about where that connection is getting proxied to after it hits those front-end services. So you need to keep that complete end-to-end connectivity in mind when you're planning and trying to configure and control where those clients connect to. Now, obviously, when we have multiple servers available in the environment, it's good to think about some form of load balancing. Load balancing simply means distributing the network and application traffic across multiple servers for the purposes of managing capacity and availability. As we go through this module, just please remember that load balancing terminology and configuration specifics will vary between different vendors. So different vendors that are making load balancing hardware and load balancing virtual appliances sometimes call the same thing two different names. So if you're used to seeing one particular term in the market or in technical documentation, I might use a slightly different term when really we're both talking about the same thing. All right, let's just set the scene with some load balancing concepts. First of all is the concept of a member or target server. This basically means a host or server that will receive traffic from the load balancer. So in our discussions here, each of the Exchange 2016 servers is a member or target server. A group of members or target servers that are providing the same service is referred to as a pool or a farm. So you'll see some vendors calling it a server farm, server pool, member farm, member pool. Each of our Exchange 2016 servers that will be receiving traffic from the load balancer is a member of the pool or the farm. A virtual server or virtual service or even a virtual IP is the IP address, or sometimes the combination of an IP address and a port that the load balancer hosts for clients to connect to. And here's a really simple example. We have a user that is making a client connection to a virtual IP that is hosted by a load balancer, and that load balancer has a pool of 2 servers, and it chooses to load balance or distribute that particular client's traffic to one of those members. So how do load balancers decide where to distribute or how to distribute that traffic to the members of the pool? Well, there are a few different methods available. The first is round robin, where it will simply rotate through the list of available members. It'll send one connection to server 1, then one to server 2, one to server 3, the next one back to server 1, and so on, just repeating that cycle. There's also weighted round robin. And in weighted round robin, it's basically the same as round robin, but the load balancer might be configured so that server 1, which is perhaps a higher capacity server, will receive half of the requests, and server 2 and 3 will share the other half of the requests. So connections are weighted a little bit more towards server 1 in that example. There's also leased connections. Now, obviously, when clients connect, they connect for a duration known as a session, and then they disconnect when they're done. So it's possible that over the course of a day, the load balancer will realize that server 1 still has 100 users connected, but some of server 2's users have disconnected and maybe it's only hosting 80 sessions at this particular time. So the load balancer will send the next connection or the next new connection to server 2 because it currently has the least connections. And finally, there's some adaptive mechanisms that some load balancers can apply, and they can take into account the load on the server, perhaps some performance metrics, the health of the server, and many other things. Load balancers have a concept of persistence. Persistence is important for stateful applications because it ensures that the application traffic continues to connect to the same host throughout the entire session. This is sometimes also known as affinity or stickiness. You might have seen the concept of a sticky session. The persistence is often based on the source IP address. So the load balancer will say that connections coming from one particular IP address must be the same client, and so it will continue to send all the traffic from that one IP address to one particular member of the pool. Now that's not entirely foolproof. There might be multiple clients hiding behind that source IP address. It might be doing some natting. So in that situation, persistence based on source IP might actually result in unbalanced traffic distribution. So there's other mechanisms as well where sometimes the load balancer or the servers involved use cookies to identify specific client connections. But it's not particularly important with Exchange because persistence is not required when you're load balancing Exchange 2016. Because no matter which Exchange server's client access services the load balancer sends the traffic to, it's just going to proxy them to the same backend server for that user, no matter which front-end service they're coming through. All connections are proxied to the active database copy. SSL bridging means that HTTPS connections from clients are passed through to the member server without being inspected or interrupted or intercepted in any way. When SSL bridging is used, the load balancer is only aware of the IP address and the port that the client is connecting to, and because of the SSL encryption, it has no visibility of the actual application traffic inside that session. With SSL termination, the HTTPS connections from the client are terminated on the load balancer, where it can decrypt and inspect that traffic, and then re-encrypt and forward the traffic to the member server. This means that the load balancer does gain visibility of details such as the URL and the virtual directory that are being requested by the client. However, this does require installation of an SSL certificate on the load balancer so that it can terminate and decrypt those sessions. SSL offloading is basically the same as SSL termination, except instead of re-encrypting the connections and using HTTPS between the load balancer and the member server, the load balancer instead sends the traffic onto the server unencrypted, so it would send it over plain HTTP. While this is possible with Exchange 2016, it's not recommended. It really is recommended to maintain HTTPS for all of your connections, even between the load balancer and the server. Load balancers can perform health checks. So the load balancer can check for the availability of Exchange server or for specific protocols that the Exchange server is serving up to clients. Each of the HTTPS services, that's services such as Exchange Web Services and Outlook on the web, hosts a healthcheck.htm file in its virtual directory. Now, if you went looking on the file system in that virtual directory, you would not see that file. It's not a real file on the file system. Instead, it is generated by application code when a request is sent for that file. So the load balancer can poll with a HTTP GET request looking for that file. It can poll every 5 or 10 or 30 seconds, depending on how you configure it. And if it gets back a HTTP 200 OK status code, well, then that protocol is healthy. If it gets a HTTP 404 not found response, well, then the load balancer knows that either the server has failed, or maybe just that protocol has failed, or alternatively, that the server or protocol has been taken offline for maintenance. Whether you're using a hardware load balancer or a virtual load balancer, you need to connect it to the network somehow so that it can perform its load balancing function. And the way that you connect it and integrate it into your network is usually referred to as the load balancing topology. And there's a few ways that you can go about doing this. The most basic topology is a single ARM load balancer deployment. In this topology, users connect to the load balancer, and then it uses the same network interface that it receives connections on to send that traffic onto the Exchange servers. The Exchange servers reply to the load balancer, and the load balancer sends that reply traffic back to the user. The other common way of deploying a load balancer is in a two-armed configuration. In this topology, the load balancer has at least two network interfaces, one that is used to receive the client connections, and the other that is used to communicate with the Exchange servers. There are also two ways that you can configure the load balancer to operate: transparent and non-transparent. When you use a transparent connection, the source IP address that the Exchange server sees is the connecting client's IP address. So in other words, it is preserved by the load balancer, and the Exchange server is able to see the real source IP address. Configuring transparent connectivity does require some extra configuration regarding routing and default gateways, and transparency is required for some protocols such as SMTP if you expect to filter connections by source IP address. So in particular on Exchange servers, you'll often have receive connectors that are responsible for permitting relay of emails to external recipients, and you'll secure those receive connectors based on the source IP address that the connections are coming from. Well, if that source IP address is being masked by the load balancer, then you're going to have a lot of trouble with that receive connector configuration. So transparency is the solution there, but if you're not able to achieve a transparent connectivity through your load balancer, well, then you can just do the filtering at the load balancer itself. With non-transparent connections, the source IP address of the connection is replaced by the load balancer IP, and this is also referred to as source NAT, or source network address translation. In a non-transparent scenario, the source IP actually can be preserved as an additional header in the traffic between the load balancer and the server. And one of the common headers that is used for this is the X forwarded for header. Now, some troubleshooting is made more difficult without that real client IP address. So if your server log's able to capture that X forwarded for header, then that's really going to help you in your troubleshooting. And we'll look at troubleshooting in one of the upcoming modules. A really important topic to understand is the difference between layer 4 and layer 7 load balancing. This layer 4 versus layer 7 concept comes down to the OSI model, which you might be familiar with from some of your computer training. It's one of the basic or fundamental concepts that are taught very early on in most IT training courses. There are 7 layers in the OSI model. The ones that we're interested in are layer 3, 4, and 7. At layer 3, the network layer, that's where IP addresses operate. At layer 4, which is the transport layer, that's where TCP and UDP port numbers come into play. So if we're talking about layer 4 load balancing, all we're able to see at that layer is IP addresses and port numbers. Layer 7 is the application layer. At layer 7, the traffic contains information such as the hostname that is being connected to and the virtual directory. So if we're talking about layer 7 load balancing, then that's when we can start to talk about exactly which hostname or namespace the client is connecting to, which is more information than just knowing the IP address and the port. Here's some examples of how layer 4 and layer 7 come into play with the load balancing. This is a single namespace layer 4 load balancing scenario. So all of the client access namespaces are configured to mail.globomantics.biz, and that resolves to a virtual IP that is hosted by the load balancer. If the client is making an Exchange Web Services request, well, the load balancer will simply send that traffic to the Exchange server, and the EWS virtual directory will do its job. For health checks in a single namespace layer 4 design, the load balancer can only check one virtual directory. The virtual directory that is selected for health checks by the administrator in most cases is the OWA virtual directory, since it's the one used when clients are connecting to Outlook on the web. Now, one of the issues with this model is that if the health check of the OWA virtual directory fails, for example, if that protocol becomes unhealthy for some reason, the entire server will be considered offline by the load balancer, even if all of the other protocols are okay. So the load balancer will send the traffic to one of the other servers in the member pool, and this entire server will be basically taken out of action because of the failure of that one protocol. Now, in a similar sense, if the EWS protocol was the one that was unhealthy, the health check would not detect that because the health check is only checking for the OWA virtual directory health. So in that situation, the load balancer might actually send the client traffic to an unhealthy service, and that's going to cause a problem for the users. When you're operating at layer 4, you can somewhat mitigate that issue by using multiple namespaces. Now you might recall that Globomantics is using two namespaces for client access. There's mail.globomantics, which is used for all of the services except for AutoDiscover, which is using autodiscover.globomantics.biz. Because those are operating on separate virtual IP addresses, the load balancer is able to perform separate health checks. So that gives us a little bit more granularity and a little bit more accuracy in detecting the true health of that server and not making assumptions based on a single protocol. But it's still not entirely comprehensive. There's still plenty of scope there for a protocol to be unhealthy and the load balancer to be sending clients to that protocol, or for the entire server to be marked as offline. So if you're still operating at layer 4, how do you completely solve this issue? Well, you can use multiple namespaces and use a unique namespace for each individual service. Each of those namespaces would resolve to a different virtual IP on the load balancer. So immediately you have a more complex load balancer configuration just because you've got more virtual IPs to configure and manage. But on the upside, each of those services is able to health check the specific protocol that it is load balancing for, and so you will get true service specific health awareness from that load balancer when it's sending client traffic to the Exchange servers. But that is a lot of namespaces to manage. So if you need that full level of granular health checking, then a single namespace layer 7 model might be more appropriate. With this model, because we're operating at layer 7 and because the load balancer is performing SSL termination, the load balancer is able to decrypt and inspect that application traffic, and it determines the host name that is being connected to and the virtual directory that the client is connecting to. This means that the load balancer can health check each individual service, and it can tell when one service is down and not mark the entire server down, so it will only load balance each service's traffic to healthy service endpoints on Exchange servers. So clearly there's a few different ways of handling that load balancer design and configuration. Here's a comparison of those three methods to help you if you're trying to make up your mind which one to go for. If you're doing a single name layer 4 configuration, that is the simplest configuration as far as the load balancer and DNS are concerned. It also generally means lower resource utilization on the load balancer itself, so you might be able to purchase a lower spec load balancer in that case and save a little bit of money. And there's also fewer names required on the SSL certificate for your servers because you're operating on a single namespace. But on the downside, there's only one health probe available on one particular protocol, so you may not detect all protocol failures. And if that one protocol that you are health checking goes down, well, the entire server is considered unavailable. If you do multiple namespaces at layer 4, you get the advantages of per protocol health probes and per protocol availability. However, you end up with more names required on the SSL certificate, which is going to be more expensive. More IP addresses are required to host those multiple virtual IPs on the load balancer, so it's now more complex. And there are also more DNS records that you need to create and manage as well. Doing everything at layer 7 means you get the per protocol health probes and the per protocol availability. You'll only need maybe one name on the SSL certificate, so you don't have quite as expensive an SSL certificate as you would with a multiple namespace design. And you can load balance multiple namespaces on a single virtual IP address So your load balancer configuration is reasonably uncomplicated in that sense, but it's more complex in terms of all the virtual services and health probes that are configured on that one virtual service. And it also typically means higher resource utilization on the load balancer itself. So you might need a slightly more powerful, which means more expensive load balancer. Now, comparing all three of these methods, the best way to think of it is that single name layer 4 is the least complex and layer 7 is the most complex. And generally speaking, you want the least complexity possible in your Exchange deployments. But all of those ways of doing it are perfectly valid. Well, after all that talk about the complexities and the pros and cons of load balancing, let's take a look at DNS round robin. A DNS round robin is not at all complicated. It simply means you are configuring multiple DNS records for the namespaces that you're running your Exchange services on. The client performs its DNS lookup for those Exchange namespaces and receives multiple IP addresses or multiple A records, and the client simply chooses which one of those A records it's going to connect to. The advantages are it's super easy to configure DNS round robin. You're just adding more DNS records into your DNS zones, which is really not very difficult at all. And it doesn't cost you anything. More DNS records does not cost money, load balancers do. However, there are some cons to be aware of. DNS round robin is not true load balancing. So you remember we talked about things like round robin and weighted round robin and least connections and how they're used to distribute client traffic reasonably evenly across the servers in a load balancing server pool. Well, you don't get that with DNS round robin. The clients will just pick whatever they want to connect to and they'll connect to it, and you're likely to get fairly unbalanced traffic out of that. There are also no service health checks. The DNS records are there in DNS, whether the server or the protocol is healthy or not. If you were doing maintenance or you knew that a server was offline, yes, you could remove one of those DNS records so clients stop trying to connect to it. But as long as it's in DNS, well, there's a chance that a client is going to try and connect to a server or service that is not particularly healthy. Now, that's not all bad. Outlook and other clients are clever enough to realize that they're failing to connect where they want to connect, and they'll look back in DNS and they'll try one of the other records, and your users might experience a 20 or 30 second delay on that particular request. Since Globomantics has decided to use DNS round robin, let's jump back into the demo environment and we'll look at configuring DNS round robin for Globomantics. So we're logged on here to the San Francisco domain controller, and we can add these DNS records in DNS Manager. Currently we have one mail and one auto-discover A record, and they're both pointing to 10.1.100.6, which is the IP address of San Francisco Exchange Server 1. So we need to add a few more A records pointing to the IP addresses of each of the other Exchange servers. But there's one other option that I actually want to configure in this case for Globomantics. And to see that option, we need to add or enable the advanced view in DNS Manager. And that gives us visibility of this time to live or TTL setting for DNS records. So let's configure the other three mail records to begin with. We'll just sort those by name, get them all together. So we have 10.1.100.6, 100.7, 101.6 and 101.7 as well. Now you may have noticed that as each of those records was created, the TTL value was set to 1 hour. It's actually recommended to run a much lower TTL record on your client access namespaces. You can safely drop that down to as low as 5 minutes or even 1 minute if you want to. It will mean some more DNS queries on your network, but the advantage is that the clients will not cache those records for a very long time. 1 hour is actually quite a long time for a client to be caching a DNS record that may suddenly become unavailable if you're performing maintenance or if that server is unhealthy. So you can drop that value down to something more like 5 minutes, and that will just help speed up any changes in DNS, such as if you remove a record for some maintenance or if because the server has gone offline and you're troubleshooting a problem. So we just need to create those auto discover records as well, one for each of the IP addresses for the Exchange servers. So that task has been completed. We've now got 4 A records for mail and 4 A records for auto discover, and they've all got nice short TTLs of 5 minutes. Let's have a look at the impact of that from our client's perspective. So first of all, we can see that the client is now resolving mail.globomantics.biz to 4 separate IP addresses. And what we should see is really no impact at all in terms of how Outlook is successfully connecting to the user's mailbox. Well, that brings us to the end of this module, in which we looked at load balancing concepts, load balancing topologies, and also the key differences between layer 4 and layer 7 load balancing, and in particular that sliding scale of least complex to most complex and what the implications of those different models are. And we also looked at DNS round robin, the nice simple way of doing high availability for your Exchange 2016 client access services, even though it's not as comprehensive as load balancing. Coming up in the next module, we're going to get into mobile access or mobility.